Okay, in 3.2, we're going to introduce what we call, now complex numbers consists of real numbers and imaginary numbers. Okay, we haven't referred to imaginary numbers before. Here's where they come up. Okay, if you have an equation that's I squared equals -1 and you square root both sides, one of your solutions is I equals the square root of -1. And we've taught you that you're not allowed to square root numbers, negative numbers. You get a no real solution. Okay, you do get no real solution. It's what we call an imaginary solution. Imaginary solutions exist in what we call a complex plane. So they're useful and we can work with them even if in real life you can't have an imaginary number of socks. Okay, so the imaginary unit is I. This tells you that a number is imaginary. And it comes from the idea if you do I squared, you get -1. I is actually the square root of -1. So, for example, if I do the square root of -25, in the past we would have said there's no real solution to this, but in fact there is a solution to this. It's an imaginary solution. Now the square root of 25 is 5. The square root of -25 is an imaginary 5. The way we write imaginary 5 is we say 5i. Okay, now what if we're square rooting an irrationals don't really exist in negative land, but let's call it square root of -3. Okay, we can't, there's no real solution to this. We're okay with this, but there's an imaginary solution. The solution is there's an imaginary square root of 3. The way we write imaginary square root of 3 is we say I square root 3. Okay, so we're just going to work with simplifying complex numbers or imaginary numbers and then doing some basic arithmetic with them. Some of these you can do in your head, and I totally respect that. Okay, so for example 1, we're going to simplify, and it says express complex numbers in terms of I, which means if it's imaginary, you're going to write it with an I on it. Okay, now the square root of -49, imaginary, because it's negative radicand. Square root of 49 is 7, so this is imaginary 7, which you write as 7i. Okay, the I means imaginary, so if it's not imaginary, don't write 7i. What about the square root of -4? 2i. It's an imaginary root, so we say imaginary 2i. How about 10 times the square root of -36? It's 10 times the square root of -36 is 6i. We can times this. 10 times 6i is 60 i's. When we're doing arithmetic, we kind of treat it as a variable, but it's kind of a special variable. Okay, now for D, the square root of -8. The square root of 8 is irrational. This is going to be some kind of imaginary answer. Okay, so let's simplify it. Okay, now how you simplify the square root of 8 is up to you. Some of you do the factor tree, which would be 4, 2, 2, 2, something like that. And then you're like, oh my gosh, it's 2 root 2. Okay, if you think it's 2 root 2, but this is an imaginary 2 root 2, we say 2i square root 2. Okay, if you would like to rewrite this as something times something, normally I would say this is 4 times 2, but you could also say this is -4 times 2. The square root of -4 is 2i. The square root of 2 is irrational, so it stays like that. Let's try the next one. Okay, this is 5 times the square root of -12. The square root of 12 is irrational, so I'm going to simplify it. Okay, let's see. Now, if you do a factor tree on the side, that's fine. I'm going to show my steps here. 12 is 6 times 2. No, 4 times 3. Yes, it's 4 times 3, but it's imaginary. There's a negative. So I'm going to say it's -4 times 3. What is this going to give me? 5 times the square root of -4 is 2i. The square root of 3 is irrational. So my final answer, 5 times 2i is 10i square root 3. Okay, and if you do the factor tree, you're going to skip this step, and you can go straight to this step. Actually, anyone can skip to that step. Okay, let's try one more. -7 times the square root of -44. The square root of -44 is, well, the square root of 44 is irrational. The square root of -4 is imaginary. Okay, simplify it in whichever way you would like. Let's see, I'm going to do it off to the side this time. That's -4 times 11. So what is that? That's 2i square root 11, which is -14i square root of 11. So this is a simplified version of the answer. It has an I in it because it is an imaginary number. Okay, we've talked about imaginary numbers. Now let's talk about complex numbers because I haven't told you what they are. Okay, complex numbers include real and imaginary numbers. Real numbers are the normal ones we kind of been using this whole time. They can be real, they can be imaginary, or they can be a combination of the two. If they are a combination of the two, we write them in standard form, which is a plus bi. So what would that look like? That would look like something like this, like -7 plus 5i. That's what we call standard form. This is real because it doesn't have the I. The 5 is the imaginary part. Okay, so that's a complex number. This one has a real part and an imaginary part, but it could just have an imaginary part. It could be like, let's see, -2i. That's imaginary. And what else could it be? Could be real. It could be like 13. That's real. That's complex. It could be a weird number. It could be like the square root of 5 over 2. That's still real. So pretty much any number in the universe you can think of is going to be complex because that includes all real numbers and all imaginary. Okay, so example one, we're going to add or subtract, and then we're going to write our answer in standard form, which means real plus imaginary. Okay, the I is a variable. We treat it like a variable. But when we write the answer, we do the real part first. Okay, I'm going to, this first one, this is adding, which doesn't affect the signs in any manner. So you don't actually have to rewrite it, though I am going to. Okay, like terms, if I do the 15 plus 7, I get 22. And then 2i minus 6i is -4i. Okay, and I did the real part first and the imaginary part second, so that would be in standard form. Right? No problem. Okay, this one. 7 plus, since it's plus, I don't need to change any signs. So let's go ahead and just combine it, which means I could have done it without rewriting. Okay, let's do real first because in standard form, real goes first. So real, -3. Imaginary, 5i plus I, positive 6i. And that's standard form, real plus imaginary. Okay, and then the next two are subtraction. When you're subtracting, you need to be careful with the signs. This is fine, but when I subtract, this becomes I'm minusing the 11 and I'm minusing the 2i. Okay, real, -5. Imaginary, 5i minus 2i, positive 3i. Okay, one more like this. Okay, 1 plus 8i. Since I'm minusing, -2 minus I, positive I. Okay, standard form, real plus imaginary. So real, imaginary. 8i plus I, 9i. Okay, let's look at multiplying. Okay, we're going to multiply. We're going to write our answers in standard form. Okay, now we treat I like a variable, but it has a special quality that we are going to use in our answers. Okay, if I do 2i times 4i, what do I get? I get 8i squared. Okay, is that standard form? No, I need real plus imaginary or something like that. So we're going to use the most important fact about imaginary numbers. That fact is that I squared equals -1. Okay, and this is the most important fact about I. Okay, why do we care that I squared equals -1? Okay, so I'm going to put 8 here. I squared equals -1. So this is 8 times -1, which means this is just -8. So if I do 2i times 4i, I actually get -8. This is in standard form. This is the real plus imaginary, but there just happens to be no imaginary part. Okay, let's try the next one. Okay, 7i squared. 7i times 7i is 49i squared. Okay, now you never leave an I with an exponent because it can always simplify. Whenever you see I squared, you think, oh shoot, I squared equals -1. 49 times -1 is -49. Okay, one more like this. -I times 3i is -3i squared. If I see an I squared, I know I can keep going because I squared equals -1. negative 3 times negative 1, positive 3. Okay, we're going to multiply a little bit more. It's going to be a little more complicated, but it's the same idea. Okay, so let's distribute here. 4i times 7, that's 28i. 4i times 6i, 24i squared. Okay, I want to do real plus imaginary. I see the imaginary part here. Okay, I see an I squared. You never leave an I squared because I squared is the most magical part of imaginary numbers. I squared is negative 1. 24 times negative 1 is negative 24. So I'm going to put the real plus the imaginary. So it's in standard form. Okay, and then this is my answer. I know. Let's try the next one. Okay, I'm going to distribute 6 times 2 is 12. If you like to box, you could box too. Plus 6i plus 2i plus I squared. Okay, let's do 12 plus 6i plus 2i, 8i. Uh-oh, we got to I squared. What do we know about I squared? Negative 1. Okay, now real plus imaginary. What's my real? 12 minus 1. 11 plus imaginary. Try next one. 20 minus 15i minus 8i plus 6i squared. 20 minus 23i plus 6i squared, negative 1. Okay, what is that? 6 times negative 1, that's negative 6. So 20 minus 6 is 14 minus 23i. Real, imaginary. Okay, let's do one more, and then you'll practice. 25 plus 5i minus 5i minus I squared. So what do we get? 25. 5i minus 5i cancels. Minus I squared is negative 1. So 25 minus negative 1 is actually 26. This is still complex because the real numbers count, and that's real plus imaginary. There's just no imaginary part. Okay, go ahead and try the practice problems. Unpause when you're ready to check the first ones. Okay, go ahead and check your answers for the first page. For 7 through 10, make sure your answer is in standard form, so it should be the real plus the imaginary. Okay, go ahead and pause. Unpause when you're ready for the next page. Okay, here's 11 through 14. And again, check that your answers are in standard form. Unpause when you're ready for the last ones. Okay, and then go ahead and check 15 through 18. For 18, make sure you squared it by timesing it by itself. Answers in standard form.